Okay guys, in this video I'm going to explain a couple of different things. The first one is this vehicle is equipped with 1234yf refrigerant, so I'm going to show you some differences on that. We're also going to tie in a performance test, some things you should be looking for, how to set that test up and look for results. So what we're going to need to raise the idle up, we're going to use this to depress the gas pedal. We're going to use manifold gauges that are specific for this refrigerant type. And then we're going to refer to this pressure temperature chart and see if our pressures are in range. So let me just show you how to hook it up. So with any manifold gauges, the first thing you should do is just open these valves. These valves tie into this yellow hose, so if you want to recover the refrigerant, it's all done through here. So what we want to do is just open these up. That'll allow the gauges to balance out. So I'm going to tighten them back up, and then we're going to hook these on one by one. So don't be afraid to connect these while the vehicle is running. It's totally safe. Watch the drive belt area and you'll be totally fine. So we'll hook up high side first, and I'll show you the really important thing here. So when we screw these couplers, this pin, this gold pin down in the middle, it actually pushes on a Schrader valve and allows the refrigerant to go into the gauge set. So we actually want to have those counterclockwise first, pull the coupler back, and then turn it clockwise to tap into the system. So I'll show you the big trick here. So we're going to hook those up. One thing I want to note is when they designed and came out with this refrigerant, both of these couplers are 1 millimeter bigger. So all of your 134A gauges will not be able to connect. You have to have this new style. So what I'm going to do to just kind of pair these up is when the vehicle is running, we're going to watch this needle move kind of, I would say, in the low hundreds on here, being that it's kind of a low temperature day. So what I want to do, I can immediately hear that refrigerant turn in. So what I really want to emphasize is when you guys are connecting couplers on any vehicle, you just want to turn it until you touch the refrigerant, and then make sure you give this another half a turn. Don't screw these all the way in, because what happens is the Schrader valves get bent and you'll take these off and you're going to get sprayed with refrigerant and you're losing time and money. So I got the high side hooked up. Let's go ahead and hook the low side up. So we'll take our caps, we'll keep our caps in our pocket. We want to make sure we retain those. So we're just going to set that guy there. So the same deal, we're just going to hook this up, turn the coupler down until we get refrigerant pressure, and there's my half a turn. So currently right now, just at idle, we're sitting about, maybe this won't work, we're sitting about, I would say 125 on the high side, and we're about 35 on the low side. So the big difference that we're seeing on these compressors is we no longer have a clutch that turns the compressor on. The compressor actually turns all the time. And so what we have back here is a variable orifice spool valve. And what that'll do is actually change the crankcase pressure, which will vary the output of the compressor. So it's a new technology that you're going to see in 1234 vehicles. So we're just going to kind of route it. Remember that there's 5 parts in an air conditioning system. We have a compressor, we have the condenser that's going to liquefy, literally it condenses it from a gas to a liquid. We're going to send it to the metering device. The metering device is going to regulate it into the evaporator, and then it's going to return. So on this vehicle you cannot see the condenser, but it's a high flow condenser, very small tubes. So this is our discharge line that's going to the condenser, and it's a little bit hard to see, but right down here, this metal line is the condenser outlet line, or we call it the liquid line. So that actually gets fed all the way along, and it's coming through right here, and this is the big unique change. So if you can see back here, it's very hard to see, but this liquid line actually is surrounding this suction line to the compressor. And so if you think about it, all of the refrigerant that was boiled off in the evaporator is just wasted gas. And so what they've designed, this thing is called a suction heat exchanger, and what that's going to do is it's going to cool this liquid down a little bit more before it gets to the expansion device. So it goes in here and it's wrapped around this line, and then it comes back out here and goes into our thermal expansion valve. So that's this guy with the little flying saucer, or the sombrero, that's what we call it. And then beyond that's our evaporator. This is our return, and remember, that's a waste. It's basically wasted refrigerant. And so once again, we're using that as an advantage to help cool the charge down. So as it returns back, that's the whole system, simply put. So what we want to do is we want to test and see if this stuff is working good. So what I've installed in the vehicle is a temperature thermometer, and I have the probe in the right vent and I have it in the left vent. And so really what I'm looking for is something between 40 and 50 degrees coming out the vents. And you can see just at idle, we're already there at 40. So I'm gonna raise the RPM, we're gonna see what the pressures are. And so I'm just gonna take this stick and I'm gonna gently hook it up to the steering wheel, and I'm gonna just slowly pump the gas until I get right around 1500 RPM. So I'm just slowly pumping it. That's probably good. We're sitting at 1500. So there's the temp probes. So now I'm just gonna walk around and I'm gonna re-observe. Just gonna kind of review my pressures. I'm gonna look at my chart and see if they're in range. So it's gonna be a little bit hard to see on the chart, but what we're looking at for a day like this, we're looking at somewhere between low hundreds. So right now our ambient temperature is pretty low. We're at like low 60s in the shop right now. Our relative humidity is low, so we should be seeing somewhere around 30 in between about 62 and 135. So this is just kind of a ballpark gauge. So I'm going to look at the gauges again now that I have the RPM up. So I am currently, looks like I'm sitting on the high side. The black gauge on the outside is our PSI, and we're sitting at about 120, and then we're sitting at about 35. So this vehicle is functioning properly. We have good pressure, good temperatures coming out of the vents. We have good pressure, and so I'm going to follow with one more quick check. So what you want to do, you want to start at the compressor and you want to field test. This is your $1,000 tool. So I'm just going to touch all these lines. So the compressor outlet line, this guy here, should be hot. It should almost burn your fingers. This line that I showed you down here, that condenser outlet, that should be really cool. It should cool down quite a bit. It's still warm liquid, but it should cool down. So by the time it wraps and goes through that heat exchanger, it should be even cooler. We've tested about a 15-degree temperature drop, which is good. So the last check is I'm just going to feel this line return into the compressor, and it's cool. It's not ice cold, but it's cool. So that is all the things you really need to know about 1234YF, doing a performance test, and just a quick system inspection. Okay, so the thing we need to conclude with is these gauges are going to hold about a quarter pound of refrigerant. So if you empty them, you put them on a scale, and then you fill them with refrigerant, you're going to see about a quarter pound. So what we want to do is we want to empty the liquid out of the gauges. So all you do is you shut off the high side coupler so we don't get any more refrigerant traveling in. We got to make sure our low is still open, and all we're going to do is we're going to open both of these gauges. So you're going to see they're going to spike and they're going to move at the same rate. And so in theory, since this high side is closed on the vehicle, we should really be just seeing what low side pressure is. And so once they've hit its bottom value, which is still about 35, we can now unscrew them and disengage them from the vehicle. And so I highly recommend that you shut the vehicle off and then take the couplers off of the vehicle. Otherwise, that's all you need to know.